topic is shortest path algorithm. Shortest path problem is about to finding the path between two vertices in a graph such that total sum of the edges is minimum. There are two types of algorithm for solving the shortest path problem. First is the single source shortest path problem and second is the all pair shortest path problem. These two algorithms perform best in their own way. So, Floyd-Warshall algorithm solves the shortest path, all pair of shortest path problem, and Dijkstra's algorithm solves the single source shortest path problem. All pair shortest path problem means if there is a graph A, B, C, D, it finds the shortest path from vertex A to vertex B, vertex A to vertex C, C to D, and then B to A, B to C, C to D, then C to A, C to B, C to D, and then from D to A, D to B, and D to C. This is the all pair of shortest path problem. From every vertex to any other vertex, what is the minimum path? In single source shortest path problem, it takes a source vertex, any of the source vertex like A, and find the shortest path all the remaining vertex, like shortest path from A to B, A to C, and then A to D. So, first we discuss the Floyd-Warshall algorithm. The approach of Floyd-Warshall algorithm is suppose we have a graph, directed graph, negative and positive both types of edges are allowed in the Floyd-Warshall. One, two, three, four. First, we find out the weight matrix of the given graph. That means, what is the shortest path from one vertex to other vertex from the direct edge? The row and column measured, labeled by number of vertices. This is the distance matrix. There is no intermediate vertex, Dij. If there is any direct edge from vertex 1 to Vi to vertex Vj, then mention the edge weight. There is no self loop, so all diagonal elements are 0. If there is no direct edge, then put it the infinity in that case. So, there is no direct edge 1 to 1. So, there is no self loop in the graph. So, put the 0. 1 to 2, there is no direct edge, put infinity. 1 to 3, there is an edge, weight is -2. 1 to 4, there is no edge, infinity. 2 to 1, there is an edge, that is 4. 2 to edge, no edge, 0, no self loop. 2 to 3 is 3. 2 to 4, no edge, then infinity. 3 to 1, 3 to 4, 2 to 4 is 1, 2 to 4 is 1. Now, 3 to 1, no edge, infinity. 3 to 2, no edge, infinity. 3 to 3, no self loop, 0. 3 to 4, edge is 2. 4 to 1, no direct edge, infinity. 4 to 2, there is an edge, weight -1. 4 to 3, no edge, infinity, 4 2 4 0. So if there is a direct edge from vertex vi to vertex vj, then put it the edge of the weight. If there is no edge is missing, put it the infinity in that case, or there is no self in the graph, so all the diagonal elements are 0. So in for Floyd-Warshall algorithm, we find the approach is, suppose we have a direct edge from vertex 1 to vertex 2, that is minimum. We find out that is there any shortest path y vertex 1? There is any shortest path y vertex 3, or there is any shortest path y vertex 2? If there is a path, then consider that shortest path. So then we consider the next matrix. It is a, in this solution we create the matrix. Now we consider the matrix y intermediate vertex 1. That means if there is a shortest path y vertex 1, so the distance matrix is Dij, distance matrix y vertex 1, intermediate vertex is 1. Row and column is labeled by number of vertices. Now here the vertex 1 is an intermediate vertex, that means the shortest path from node 1 is remain same, it is unchanged. So copy the row and column of the first row and first column, because the shortest path from vertex 1 is remain same. Always copy from the just previous matrix: 0, infinity, minus 2, infinity, 4, infinity, infinity. So we copy first row and first column. There is no self loop in the graph, so all the diagonal elements are the 0. Then all the diagonal elements are the 0. Now we calculate the value of 2, 3. That means the distance of 2, 3 in vertex, from vertex 2 to 3 in 0 matrix, the 2 to 3 is 3, and the distance of by vertex 1, that means the distance of 2 to 1, just put middle of the 1, 2 to 1 and 1 to 3, plus distance 1 to 3 in just previous matrix. Then 2 to 1 is 4, and 1 3 is minus 2, that is 2, and this is less. So there is a shortest path from vertex 2 to 3 y node 1. There is shortest path from vertex 2 to vertex 3 y node 1. 4 minus 2 is 2. So replace it and put it here 2. Now calculate the distance of 2 to 4 y vertex 1. 2 to 4 distance is, first calculate the 2 to 4 from previous matrix and put the intermediate vertex, like 2 1 plus 1 4. That means 2 to 4 the value is 1, and 2 to 1 is 4, plus 1 4 is infinity. 4 plus infinity is infinity. which is less, 1 is less. So, there is a previous shortest path, 1 is the shortest path. So, put it 1. Using this approach, we calculate all the values of the distance matrix via a vertex 1. So, that is now we calculate the distance matrix from vertex vi to vertex vj via a vertex 2. Dij y vertex 2. The row and column is labeled with the number of vertices. Now, from 2 vertex 2, the edges are same. So, consider copy the just second row and second column, infinity 0, infinity minus 1, 4, 0, 2, 1. And with all the diagonal elements are 0. All the diagonal elements are 0. Now, calculate the value of 1, 4. The value of 1, 4 is y vertex 2 is infinity plus comma infinity, infinity 1 3. What is the value of 1 3? That is minus 2 or infinity, that is minus 2. Infinity and infinity, that is minimum, that is infinity. What is the value of 3 0? The value of 3 0 is infinity, and from this is also infinity, then it is infinity. The value of 3 4, the value of 3 4 is 2. From here the value is infinity. So, from 2 and infinity minimum is 2. Now, calculate the value of 4 1. The value of 4 1 means the distance matrix of 1 4 1 and put the intermediate vertex, यानी कि 4 2 plus 2 2 in the previous matrix. The value is 4 1 is infinity and the value is 4 2 4 2 4 2 is minus 1 plus 2 2 plus 2 2 is 0, that is 0. So, in infinity and 0 and infinity and minus 1, which one is minimum? Minus 1. So, answer is minus 1. Sorry, 1. Now, calculate the value of 4 1. The value of 4 1 is 3. So, in this same approach, calculate all the matrices that are derived by a vertex 1. The intermediate vertices are always the total number of vertices in the graph. So, it is a dynamic programming approach, that means at each step we take a decision. Next, it is an optimal substructure of the shortest path, that means any subpath of a shortest path is the shortest path. In this, we create a 2D matrix where we calculate the Dijk value, which is the shortest weighted of any path from vertex I to vertex j, where all the intermediate vertices are the set from the vertex set 1 to k. That means all the intermediate vertices are from the set of the vertices. And ultimately we would like to know the what is the value of dij. So, as we see, the value of dij is the weighted graph if there is no intermediate vertex, or if there is an intermediate vertex like 1, 2, 3, then the distance matrix is the minimum of dij, then put the intermediate vertex k, ik plus kj from the previous matrix. So, this is the formula to calculate the dij. Now, what is the algorithm to calculate the Floyd-Warshall matrices? The matrice in, as we know, in matrices row and column are labeled by the number of vertices. So, from here it is used to print a single matrix. This is for row from I to n and for column j to n, and we always do the minimum of dij and dik to ikj. And there are n number of intermediate vertices. If there are 4 vertices, so there are 4 number of intermediate vertices. So, we use the k, where k is the 1 to n, and solve all the. So, there are 4 number of matrices to be solve this problem. So, there are 3 loops from 1 to n. So, the time complexity is order of n cube. So, just continue with an example to find out the shortest minimum all pair shortest path of the given graph. So, first we calculate the weight matrix. The row and column is labeled with the number of vertices 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If there is an direct edge, put the edge value. If there is no edge, put the infinity, and there is no self loop in the graph, then all the diagonal elements are the 0. So, as we see, there is 4 to 1, 4 to 1, the edge is 2, put 0, 4 to 2, there is no edge, 4 to 2, so put infinity. To calculate the simple weight matrix, that is the distance 0 matrix, because there is no intermediate vertex. Now, calculate the D1 matrix, that means the shortest path through Y1 through vertex 1 in this. So, to calculate the D1 matrix, we always use the D0 matrix, just previous matrix. Put the first row and first column, because the path from first node is remain same, first row and first column. Just copy it from the previous matrix, and all the diagonal elements are 0. Then all the diagonal elements are 0. Now, calculate the all values using this formula. Okay. Like calculate this value. Calculate the value of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, calculate the value of 4, 2. So, calculate the value of 4, 2, that means just see the 4, 2 value from the just previous matrix, and in previous matrix put the intermediate vertex. Intermediate vertex is 1, that means 4 to 1 plus 1 to 2. Just see what is the value of 4, 2 in previous matrix. The value of 4, 2 is infinity, and what is the value of 4, 1? The value of 4, 1 is 2, and the value of 1, 2, the value of 1, 2 is 3, that is infinity and 5. Which was is minimum? Minimum is 5. So, put the value is 5. Now this is the distance matrix via vertex 1. Now we calculate the distance matrix via vertex 2. For calculating the matrix via vertex 2, always use the just previous matrix, and in this we copy the second row and second column, because the path from second row and second column is remain same, and all the diagonal elements are 0, and calculate all the values of the matrix by using this formula. Now calculate the distance matrix 3 by using distance matrix 2 and copy the third row and third column, and all the diagonal elements are 0. Third row and third column, and all the diagonal elements are 0. And just calculate the matrix D4 just from the previous matrix, यानी कि find out the shortest path from vertex 4. to calculate, just select the fourth row and fourth column from the previous matrix. That means the direct path from node 4 is remains same, it is not changed, and all the diagonal elements are 0. All the diagonal elements are 0. Let's see the calculate the value is of 5 1. 1 2 3 4 5. 1 2 3 4 5. Calculate the value of 5 1 from the previous matrix. So calculate value of 5 1, that means in previous matrix the value of 5 1, and put the intermediate vertex in between. The intermediate vertex is 4, that means 5 to 4 and 4 to 1 in just previous matrix. The value of 5 to 1 in previous matrix, 5 to 1 is infinity, 5 to 4 is 6, and 4 to 1 is 2. So 6 plus 2 is 8. In infinity and 6 plus 2, 8. Infinity in 8, what is minimum? Minimum is 8. Then put the value 8 here. Now calculate the distance matrix 5. That means the shortest path via vertex 5. So calculate the distance matrix 5 by using this formula and copy the fifth row and fifth column from the previous matrix, and all the diagonal elements are 0, and calculate all the values by using this formula. The final matrix, that means there are total number of vertices is 5, then calculate up to the distance matrix 5, and that is this matrix is your final answer. This is the all pair shortest path from vertex 1 to vertex 2 3 4. This is the all pair shortest path of from vertex 1 to vertex 2 3 4 5, from 2 to 1 3 4 5. Like there is a shortest path from vertex 5 to 1, from vertex 5 to 1 is 8, that is this and this, 6 plus 2 8. There is no other option to calculate the shortest path. This is the shortest path. So final matrix, total number of vertices in the graph, then calculate the distance matrix of to the total number of vertices, and that final matrix is the all pair shortest path. So this is the final answer. So through in Floyd-Warshall algorithm, we use the dynamic programming. That means at each step we take a decision, take a sequence of decision, or we calculate the matrices by using this formula. Now what is the Dijkstra algorithm? It is a iterative algorithm that finds the shortest path from vertex source to other vertices, from single source to all remaining vertices. It can work on directed and undirected graph, but negative edges are not allowed. Only non-negative weights are allowed. The graph must be connected. Generally, the applications of the discussed is in the map and the computer network to find out the best route between the locations. The time complexity of the discussed algorithm is the V square if the graph is represent as adjacency list, if or otherwise the complexity is E log V if we use the binary heap. So, the approach of discussed algorithm is continue with an example. O2 and we want to calculate the shortest minimum path from source vertex A to all other remaining vertices. From vertex A, what is the shortest path from A to B, A to C, A to D, A to E and A to F. The approach of discussed algorithm is that suppose just take a small graph A, B, C, 2, 4. If there is a path from vertex A to B, so the shortest path from A to B is 2 if there is a direct edge. So, there is a direct edge from A to B, so the shortest path from vertex A to vertex B is 2. But there is no direct edge from vertex A to C. So, there is no shortest path. Initially the shortest path is infinity, that means there is no path from vertex A to vertex C. But through vertex B, that means if there is an edge between U to V and distance of U, if distance of U plus weight of U and V is minimum to distance of V, then the distance of V is replaced by distance of U plus weight of UV. That means distance of U, the distance of U is 2 and the weight of U is 4, 2 plus 4 is 6, 6 is less than infinity, that is replaced by the 6. So, there is then a path from vertex A to C, but why vertex B? 2 plus 4 is 6. So, in that case we replace the distance of V by 6. This is known as the relaxation. Relaxation of the vertices, in which the difference between two vertices are du plus cost of the edge with sum up is minimum to the weight of the vertex V, then replace the distance of vertex B by the distance of U and the cost. So, same approach is followed in this example. The source vertex is 0, the distance from source vertex is always 0 and the all other vertices is infinity. All other vertices is infinity. Now, check from source vertex to direct edge from source vertex to other vertex. So, there is a direct edge from vertex A is 2 and 4. So, 0 plus 2 is 2. Now, relax the vertex B infinity and replaces 2 and replace it with 4. Now, the Shortest path from A to B is 2 and A to C is 4. Now select the shortest one, all the remaining nodes. In 2, 4, infinity, 4, infinity. In infinity, what is the minimum? Minimum is 2. Then select the vertex B. Now from vertex B there are 3 edges, 4, 2, 1. Now relax the vertices. 2 plus 1 is 3. Now the weight of C is 4. Relaxation. The weight of V is 4, or if the weight of U plus cost is minimum, then replace it with minimum. So 2 plus 1 is 3, then replace it with 3. 2 plus 4 is 6, replace it with 6. 2 plus 2 is 4, replace it 4. Now the minimum from vertex 6, 3, 4, infinity. So minimum is 3, then select the vertex C. Now relax the vertices. 3 plus 3 is 6. Condition is false. So does not change the weight, does not change the distance of the vertex E. So now what is the minimum between 6, 4 and infinity? Minimum is 4, then select it. Then relax the vertices. 4 plus 3 is 7, this is already minimum, so can't change. And 4 plus 2, 4 plus 2 is a 6, here is a infinity, then replace it and place it 6. Now the minimum between 6 and 6, both are same, select any one. Suppose we select D. Now 6 plus 2 is 8, or here already is a minimum distance, so select is 6. Now select F. Now there is no adjacent vertices to F, then stop. So from source vertex to A, so from source vertex A, source vertex A, the distance to vertex B is 2, A to C is 3, from A to D is 6, D to A to E is 4, and F to 6. So this is the shortest path from vertex A to all the remaining vertices. So this is the approach of the discrete algorithm. So in this, what is the algorithm says? The algorithm says that the distance of the source vertex is 0, as we told in the previous slide. Always said the distance of the source vertex is 0, and all the remaining vertices to infinity. Initially the visited vertices is empty. Initially which vertices we are visiting is empty, and Q is the queue initially contains all the vertices. Now when the while loop कब तक चलेगा, जब तक हमारा Q empty नहीं हो जाएगा. Find the minimum distance from, find the minimum distance of the Q and add this distance to the, add this distance to S and visiting, add it into visiting vertex. So same, this is the relaxation procedure. If the shortest path found, if the shortest path found, set the shortest path to the vertex V and contain this loop until the Q is empty. So continue with another example. Suppose there is a graph and we want a shortest path from vertex A to all other vertices, from vertex A to B, A to C, A to D and A to E. So initially A to 0, initial source vertex का distance है 0 और all remaining vertices का distance है infinity. तो we maintain a Q, source vertex distance is 0 and other vertices distance is infinity. Now we traverse from the A. The direct edge from vertex A is 3 and 10. This. Now we visit the vertex A, and the cost is from A to B is 10 and A to C is 3. Which one is minimum? Minimum is 3. So select the 3 and find out all the adjacent edges from vertex C. From vertex C there are 3 edges, C to E, C to D and C to B. B के लिए वेट क्या हो गया 3 plus 4 7, 3 plus 4 7, ऑलरेडी क्या था 10, तो रिलैक्स द वर्टेक्सेस एंड रिप्लेस 10 by 7. C to D 3 plus 8 11, infinity and 11, which one is minimum? 11 is minimum, so replace it by 11. 3 plus 2 5, infinity and 5, which one is minimum? Minimum is 5, then replace it with 5. So vertex C is visited. Now which one is minimum? Minimum is 5. So select the vertex 5 and find out all the shortest path from vertex E. From vertex E there is only one shortest path from vertex E to D. The weight is 9. 9 plus 5 is 14. Now already the weight of the distance of the vertex D is 11. So we cannot change, because if there is a minimum then replace it. So already is 11. Now which one is 11? 7 is minimum. Now select the B. From V there are 2 paths, from B to D and B to 1. From B to D 7 plus 2 is 9, or here is 11, so replace it with 9. Replace it with 9. Now which one is minimum? 9 is minimum, then select it. Now all the vertices is covered. All the find. So from vertex A to B shortest path is 7. From A to C shortest path is C. From A to D shortest path is 9, and from A to E shortest distance is 5. So this is all about the discussed algorithm. Now do the questions on the following graph. Consider the following undirected graph shown in the figure. Using discussed shortest path algorithm, find out the shortest path from vertex A to all other vertices. This is the question number 1 and this is the question number 2. Find out the shortest path from vertex A to all other vertices using discussed algorithm. In the second question, consider the following graphs and determine the shortest path between all pair of nodes. That means apply Floyd-Warshall algorithm from all pair of vertices. Find out the shortest path. These are the references. Thank you so much.